Hi, my name is Aldo Navarro, and today I will do the code review for the computer science capstone. First, I will describe the three artifacts in the three categories: software, engineering, design; two, algorithms and data structures; and three, databases. First, category one, software design and engineering. I will provide a clear and complete description of the existing code functionality. First, I will show you how the application works and how the code is structured. First, I will show you how the application works. I will run the app. The application is developed in Android Studio, and it is emulated using the Android Studio emulator. You can see how the application is presented. We have a login screen. We use our credentials and login. The, the login screen also works as a sign in with this button, create credentials. But as we already have credentials, we are just going to log in. The first thing I'm going to show to you is the menu. Here we have various functionalities of the solution: add inventory, see inventory, edit inventory, notification settings, and logout. If I want to log out, if I want to log out, I if I want to here we can see how the application is presented after we log in. We are shown the inventory table view, and there is a side menu with various functionalities about the solution. And add inventory view, see inventory view, which we are seeing now, edit inventory, and the notification settings and logout. If we want to log out, we tap and we are logged out. The text boxes are cleared, and if we want to log in again, we log in again, and we are shown the same view, inventory table. We can add inventories. We have product name, product one, description, product description, unit, kilograms, quantity 56. We submit it, and the ID field cannot be empty. We're gonna do an ID, and submit. It was added successfully. Now we're gonna go to see inventory, and here we have it. Product one, about description, kilograms 56. If we want to delete it, we're gonna select it and delete selected, and it is deleted. Next, we already have seen the add inventory. If we want directly to go to the view of add inventory, then if we want to go to the edit inventory, we're gonna search for an inventory, which is, I don't know, 10, search. We have here, and we're gonna edit the quantity, 88, edit, and success editing the product. Next, the notification settings. Here we can see how the app permissions are handled, where we are only using SMS permission status, which is granted right now, and the notification. And why we want the SMS permission status? Because we are receiving various SMS notifying us the about the stock status. We are sent a low inventory alert about three IDs, 15, 11, and 5, with the product and quantity left. If the quantity left is less than 10, we are the alert is shown here as a data field. Next, I will describe how the code is structured and how it works and what does it do. The application entry point is the main activity, which handles which view is present, whether a button and menu button is pressed or is not. For example, when the main activity is created, a toolbar is also created, along with a drawer layout, a navigation view, a navigation controller, and an app bar configuration. All these objects create the side view menu, which are defined by these XML resources within that graph, for example, which has the navigation of add inventory, all inventory, edit inventory, settings, and logout. Next, the main activity also handles fragments. What are fragments? The navigation view, along with the layout of the menu, also has each item related to a fragment. For example, the add inventory navigation item is related to the add inventory fragment. When I press the add inventory item, a fragment is created. If it is the first time being created, the onCreateView method is called. If not, it is an onResume method is called. Here, all the application logic of the add inventory fragment is defined. For example, in this case, add inventory has a database manager, various text boxes, and two buttons, submit and cancel. Submit and cancel. On each button, a callback is defined. Is defined along with interfaces that define what happens once it is clicked. For example, once the submit button is clicked, uh, all the text boxes, all the text on the text boxes are casted on strings objects. For example, ID box text is now on the string ID. Next, we validate each string of the data fields. We validate that the ID string is not empty. If it is empty, a toast is sent to the application. For example, if the product string is empty, a toast is sent to say to the user a product field cannot be empty. If a quantity is empty, quantity field cannot be empty. Then we parse the quantity from string to integer. Finally, we call the database manager and we create an inventory field with the product, description, unit, and quantity. If the create inventory method outputs a failure, we send a toast with the text submit failed. If the create inventory methods is successful, we send a toast added successfully. Finally, we empty all the text boxes. Similarly, the cancel button also has a callback with an on-click interface. This button, when pressed, makes all the text boxes empty. We can see how a fragment works. Each other fragment works similarly. For example, the all inventory is more complex. See inventory. Here it has checkboxes to see, to check which inventory item I want to delete. If we see here, if we see here the delete, we check all the checkboxes on the delete checkboxes on the delete checkboxes list. And if a box is checked, we delete the row, and we delete the row for the user to not see it anymore. And we call the div manager to delete the data field in the database. So next time we enter the inventory table view and the table is updated, we also do not see the item, the data field. As you have seen, every now and then a notification is sent to the to, to the emulation phone. It is because there is a procedure in main activity. Here, the minute task, we check the run interface. We check if we have the permission granted. If not, we send a toast. We tried to send an SMS, we need a permission. However, if we have the permission, we do the whole procedure to check all the items which have low inventory items. Here, if we see the low inventory managers in DB manager, here, get low inventory items. We have the columns and we query. We query with the selection arguments of 10. We select all the columns that have a quantity below 10. We go back to the main activity, to the minute task, which is a runnable. A runnable is a task that runs in the background each X amount of time. And we get the low inventory items and we send the message. We build the message. You have seen low inventory alert, ID, ID, product, and quantity left, 479. We append the quantities, all the data fields. We are here we first create the message builder, and we delay 2 minutes. Now, how can I improve the inventory application from the course CS 360 Mobile Architect and Programming? How can I improve it? The best course of action to improve, to making enhancements to the application is to, for example, as I have described on the module 1 assignment, I want to enhance or add features like invoice, printing of invoices or other documents, and data visualization. Why invoices? Because inventories work together with sales, and sales work with invoices. So my plan is to create additional tables for the database and create an invoice manager that will also handle the creation and deletion of invoices alongside other features like printing. I'm gonna use a print library and also a document rendering library to create the document, save it, and have the option to print it or be shown in the application. Additionally, if I'm gonna have uh, a table with my sales, I'm also gonna I'm also will want to make a feature for the employees to visualize data. For example, the monthly sales of the company, how the company compares sales between months or years with pie charts or normal charts. Also, the main application also has, as you have seen, backends. My main backend is my database inventory helper, which helped me to create the tables, to define how the tables are made, and the inventory manager, which which uses the inventory helper and creates queries as methods. For example, check login, checks the login credentials, and sends if the login is credentials match any columns, any rows in the database, in the table of users. Next category, algorithms and data structures. For the category 2 algorithms and data structures, I am using the artifact of the final project of the CS 330 computer graphics and visualization, which was developed using C++ and OpenGL API. First, I'm going to show to you how the application works. The application is starting. It's a mockup of a composition of objects with texturing, lighting, uh, texturing, lighting, and composition of primitives. For example, this candle light and the candlelight holder are many primitives from toruses to cylinders to cones to rectangles to boxes to tapered cylinders and spheres, many primitives. Additionally, two lights are present. Additionally, a camera work is on so I can navigate the composition with other views. For example, an orthographic view, side view, top view, and back to the perspective view. Also, with the mouse wheel, I can make the speed. I can increase the speed, and also I can slow the speed. Increase, slow. Now, I'm going to describe how the code works and how it's structured. The main entry point of the C++ application is the main method. We are using OpenGL and GLSL shaders. First, the main application creates GLFW, which handles window creation. Then, when the window is created, we load the shaders with the shader manager object. We create as a scene with the shader manager. We prepare the scene, and here we have our main loop. It's defined by a condition. The condition is if the GLFW service does not send a close event, the application continues. Here, the close event for the application is the escape button, which is handled by a callback, which we're going to see later. Here, each loop is a entirely new frame. We clear the swap buffer, the back buffer. We prepare the scene view with we load all the primitives, we load all the textures, and then we render the scene. Once rendered, we swap buffers with the front buffer, which is what we are gonna see on our main window. Then we pull the events and check again if the window must be closed or not. The second most important module of the application, of the OpenGL application, is the scene manager. The scene manager handles all the logic of the whole scene, from the primitives, to the linings, to the materials, the navigation controls, anything. For example, we create, the scene manager also has the scene manager also has helper functions to create a texture and load it, to bind textures to GPU memory, destroy textures, to find textures, many other helper functions. The main functions I'm gonna describe here is the loading, the load, all the scene textures. Here we can see all the textures that we are loading, and we are binding them to the OpenGL memory slot. We prepare the scene like in the entry point main main loop code. We define the object materials, we set up the scene lays, we load textures, and we load all the meshes that are going to be present in the scene. Next, we render the scene. Once we render each primitives with all their matrices, with the rotation, with the translation matrix, with the scale matrix, with the XYZ rotation matrix, which we create here in the set transformations method. Finally, when a primitive is ready to be rendered, we call the basic meshes and we draw the plane mesh. Also, we can see that we bind each mesh with a texture. Here, the first mesh we're going to draw is a floor and with a material 0. And then we draw the plane mesh. Because the logic is so repetitive, I created functions to render whole objects made of many primitives. For example, I have my render candle function that with the input of the scale, the rotation in XYZ, and the position XYZ. I render the candle. What does it do? Here is the definition. It's basically the same procedure, but encapsulated in a method that holds all the required primitives to be rendered for the whole object to be rendered, along with each offsets that create all the composition of one object. For example, the candle light has many cylinders with an offset, as a cylinder, as a handlebar, a torus that helps the handlebar to be attached. Other objects like the candle cover also have their functions. And that would be how my application for the CS330 is made with all its features. Now I'm gonna analyze how the code is structured. I think overall the code is very good at structuring and abstracting all their classes. However, I think the render scene is very confusing to read because it is so repetitive and very large. So if a new developer comes to the project and sees this whole method that is called each frame, it's very hard to understand what is doing. Also, I have made many other methods to help me handle translations and rotations, and scaling, because some objects require a different order of translation. For example, I have made an initial transformation object, which is a 4x4 matrix. Here I first do a scaling and then a translation. Other objects, I do first a rotation, then a scaling, then a translation. Other objects, require first a translation, then scaling, and then a rotation. So each object has its own requirements of transformation. I would like my I would like that the objects don't require such complex managing of many matrices and how they're handled. Um, Maybe other solutions are better, but I think this is how this is one of the code weaknesses about how it works. Finally, many meshes can only be loaded one one time. Even if I want two meshes, for example, the torus can be loaded with different radius, with different inner radius and tube radius. If I try to render a different torus with different radiuses, I need to unload the mesh and load it again. This makes each frame to load and unload meshes many times per frame. So this is why it makes the solution a little jerky and with low frames and not as smooth as a computer graphics application would be, as a real-time compares computer application would be. Finally, I will describe my proposed enhancements for this artifact. First, I will solve the low frame rates that are caused by the loading and unloading of primitives, especially the torus, because I need many configurations of the same mesh of the torus with different radiuses. So I will add the feature of creating not just one toruses and loading it and unloading it, but create many different sources in the same memory slot. So with the change of memory usage, I will gain more frame rate because loading and unloading is very CPU intensive and GPU intensive. It is faster to load many similar meshes than unloading and loading many others. My other major enhancements would be a graphic user interface, which will use DRM and GUI, is fast and easy to implement. Then I'm gonna implement also a thread pool to run code simultaneously and make my application more efficient with less single thread usage and distribute the CPU load with many threads. For example, my CPU has 16 threads, so the plan is to make each thread to use as many tasks as possible. Once I have implemented my thread pool, I will use the GUI to create an inner window that will show a chart, a live chart, which will show how many tasks are in the queue, in the task queue, and how many are being run. Additionally, my plan is to create other window to have like a list of all the objects present in the composition and how I can edit them. For example, their X position, their Y position, and their Z position. To develop, finally, I want to show the capabilities of my thread pool. So I will implement a CPU intensive task that will be run simultaneously for X amount of time, and we will see it how the tasks are being sent to the queue and how they're being sent to each CPU and being run. Next and final, category 3 databases. The category 3 databases artifact is from the CS340 course client and server development. Here's my project. Right now it's being run, and here it is. It is a dashboard which shows a rescue animal database from the Austin metropolitan region. The dashboard has many options, for example, filters. I want animals that were rescued in the mountains, and here they are. I can see where they are located, and the map is being focused on the location. Additionally, a pie chart distribution is shown with the breeds and their percentages. For example, the Siberian Husky has 40% on the mountain rescue filter. The Alaskan Malamute is 20%, and the Rottweiler is 20%, and the German Shepherd is 20%. We can see that there are two Siberian Huskies which are correlated to the 40%. We have a disaster rescue, which also changes immediately once I change the filter. Here also, for example, here the water rescue is all Labrador Retriever mix, and we reset. We have all the all the all the breeds shown here. Here they are. As you can see, the pie chart glitches a little bit because of all the data that is being presented. The table has also column filters with ascending and descending options. And finally, if I want to focus, as you have seen earlier, I can focus any row with the respective location yourself. So how this project is structured? It is quite small, but it uses the Dash library along with the Dash leaflet library, which helps with the creation of charts and the rendering of the server. And also I have created a, a module that handles all the database related logic as a Python module, and it is defined as shelter. The shelter requires credentials with a username and a password. The database is handled by MongoDB. The database is created, the database object is created, and the data frame is read. from the data frame object. We create the app layout, which is basically a single page HTML file, which has many divisions, headers, but mainly has the division for the logo, the division for the filters. Here we can see water rescue, mountain rescue, disaster, which has radio items. You can see here the radio items. Next, we render the data table with all the configuration that we want. We want the data table to be selectable, so we can select each row and define a logic for the relationship between the table and the map. Next, we have the last division, which has the graph, the pie chart, and the map. Here, the website ends, and we create the callbacks that will add the functionality and features of the whole dashboard. For example, the update dashboard has the input, outputs the data table, and inputs the filters. If I change the filter from the radio items, the callback is called, the function callback is called. And we see, for example, if we have selected the filter A, which is water rescue, we filter the data frame, breed column with the Labrador Retriever mix, the Chesapeake Bay Retriever, and the Newfoundland. If we selected the filter mountain rescue, we filter the breed with German Shepherd, Alaskan Malamute, Old English Sheepdog, Siberian Husky, and Rottweiler. And to be intact male also in the water rescue. And the age upon weeks between 26 and 156. And similar here. Finally, the selected filter C is a disaster rescue. Here are the breeds. This is upon outcome, and the sex and the age upon outcome in weeks from 20 to 300. And we return the filtered data frame to the dictionary of records. And we have the new data table with its new data, and it is updated. Similarly, is made with update graphs, update styles. Update styles is made when I select when I select a column and a row. When I select a row with this checkbox, all the row is made of a single cyan color. Next, we have the update map callback. It is updated when the data table data and the data table selected rows are changed. This is when I change this or this. The whole map updates. It returns a new map with a new focus location and scaling, everything. I think the artifact code for the category 3 is very is successful in structuring how the code is handled and how the callbacks are handled. The callbacks are the main application logic and how the solution comes from a static page to a dynamic page. However, it has some issues. For example, let's say I have here, I am in the row 9, and it is working properly. But what happens if I do the filter less rows than the one I am selecting? Here, I have the callback error updating my children because it doesn't find the 9th row, even though there is a 9th row. Finally, my proposed enhancements are the following. I will want to create another dashboard with the public's perspective on animal care and animal rescue. The data will be collected using Beautiful Soup and Selenium packages. And the data will be processed, analyzed, and displayed as an interactive dashboard with one or two graphs, new graphs that can be filtered and animated.